This week, learn about Dateutil, how it can make your date string parsing easier and your relative deltas one-liners. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I want to show you a handy utility that I recently found called Dateutil. Now, you can install it with Conda from the Conda Forge channel using dateutil-python as the name, or you can pip install it with the same name. This is a really nice utility that builds on the functionality of Python's core datetime object, making natural string parsing a little bit easier. It has some fuzzy logic matching that's pretty nice, as well as dealing with relative deltas in a pretty clever way. Now, it has a lot more functionality than what I'm going to go into today. You can certainly do things like tell me the next year that this holiday is going to be on a certain day of the month or the third Tuesday or whatever, but that's not generally what we're trying to do in meteorology. So assuming that you've got Dateutil installed, which again could be done with conda install -c conda forge python dateutil, or similarly with pip install python dateutil. It is Python 2 and 3 compatible. The way their examples are done, they use import star quite a bit, or the wildcard import, which I'm not a big fan of. So we're just going to import the things that we need. So to start off with, let's try some simple parsing. So from dateutil.parser, I'm going to import parse. Now in the regular datetime, string parse time, you have to get really specific with how you specify the formatting of the date string. Pandas has some fuzzy matching, but you have to be using pandas. Here, let's just call parse, and let's provide a string that looks something like Sunday, May 17, 8:12:34 p.m. And I'm going to tell it nothing else. And we get a datetime object back for the 5th month, 17th day of 2020 at 20:12:34. Notice it even handled the PM, and I didn't have to tell it anything. Now, that is pretty versatile, so let's try a different example. I'm going to parse sun 5/20/20 at 8:12:34 p.m. And we see that also works, but Sunday is not the 20th day of this month. So it is ignoring some information. It's saying that doesn't fit my schema, but I know that this is a date here, and so I'm going to trust that. Let's see what happens with less information. So if I just say parse 8:34, well, by default, that gives me today at 8:34 a.m. So again, it is making some assumptions for you, and instead of just erroring out, so it's very useful, but they may or may not be the assumptions that you wanted it to make. Just something to be mindful of. Now, let's look at another example. I'm going to parse 05-17-20, and unsurprisingly, that works at 0Z. Now I'm going to parse 17-05-20 using the day first. And that also works. So it was able to detect that this indeed is a date of the 17th of May. Now, what happens if it's an ambiguous date, such as 06-05-20? Well, it assumes month, day, year, unless it is non-unique, such as this. All right, well, if it is a day first date, all we have to do is set the day first kwarg to be true, and then we get the correct parsing. So again, it tries to make a sensible assumption, and if that assumption doesn't fit what you need, you can modify it with some of these keyword arguments. But now let's get to some of the really cool fuzzy logic matching. So I'm going to parse the event was predicted to occur on 5/20. So we get a parse error. Well, we've got a lot of things in there that aren't a date. This could be the text of an area forecast discussion. All right, now I'm going to say fuzzy equals true. And there we go. Now we get a parsed date. Again, it makes some assumptions like that it was this year. You can go in and change those assumptions. If this is an AFD from 2018, but you want to pull out the month and dates, you can certainly do that. All right, let's look at one more example of the parser. I'm going to parse the string today at 8:30 p.m. with a time zone of -4. And if you want to know more about time zones, I encourage you to look through their documentation. It's too much to cover in one video. That's something we could certainly do in a future video. But there we go. We get an offset of 14,400 seconds or 4 hours. And it uses a standard time zone database because time zones are something that are really terrible to have to deal with. All right. The last thing I want to show you in this quick intro to Dateutil is the relative delta function. So from Dateutil dot relative delta, I'm going to import relative delta. I'm also going to go ahead and from datetime import datetime. So let's look at what datetime.utc_now produces. Well, this is something we're all familiar with. It is the current time, year, month, day, hour, minute, second, microsecond. Okay, so let's do something that would be a little bit harder to do. Not impossible to do with the core datetime object, but a little bit harder. Let's say I want to get yesterday's radar at 13:15Z. Exactly. I'm going to call datetime.utc_now and add a relative delta. Notice add, not subtract, of days equals -1. So if I just do that, we get now, but a day ago. You see the 17th. The plural are the deltas, so days, hours, minutes, seconds, and so on. But then you can also set, using the singular, the value. So I don't want to delta hours, but I want the hour to equal 13, the minute to equal 15. And I'm going to go ahead and line wrap the second to equal 0, and the microsecond to equal 0. So now we have a datetime object for yesterday at exactly 13:15Z. Again, you could do this with datetime using time deltas and then resetting those hour, minute, second, microsecond values, but this is a really nice one-line way to do it, and I kind of like the syntax, so it's a little subtle, of days and day to say a delta or something that you're setting with an absolute value. I hope that you found this useful, and I'll see you on next week's MetPy Monday.